let us discuss about OSI model. OSI means Open System Interconnection. This is one of the topic in computer networks. This is the diagrammatic representation of the OSI model. First, see the definition of the OSI. OSI means for Open System Interconnection. It was developed by the ISO, International Standard Organization, in the year 1984. Okay, the first OSI means Open System Interconnection. Open System Interconnection, and it was developed in the year 1984 by ISO, International Standard Organization, ISO. Okay, it is deals with how the systems are connected through the worldwide. This contains 7 layers, starting from application layer to physical layer is the starting layer, and application layer is the final layer. While we see this in two sides, one is sender side and another one is receiver side. While in sender side it was a top down approach, while in receiver it's bottom up approach. Okay, these are the 7 layers of the OSI reference model. Okay, physical layer is the bottom layer, the next one is data link layer, network layer, transport layer, session layer, presentation layer, application layer. Okay, OSI mainly deals with how the systems are connected. Okay, it was developed by the ISO, International Standard Organization, in the year 1984. Okay, now the first layer is physical layer. It mainly deals with in physical layer the data in the forms of the zeros and ones. We transmit the zeros and ones from one host to another host using physical layer. The data which is always in the forms of binary 1 or 0, this raw data is transferred through physical layer. Okay, the second one is data link layer. In data link layer we introduce the new concept frames. Okay, the raw data 0 and 1s are divided into small frames. Okay, these frames are used for error free transmission. Okay, this data link layer, we take this raw bits data and we convert them into frames and transfer through the data link layer. The next one is network layer. Network layer used to find the best path to transmit these packets, these data frames convert into data packets. This network layer provide the best route to transfer these packets. In transport layer we divide these packets into small segments. These segments are collected from these segments are here from host A to host B. These segments are divided at host A. At the same time, these are collected at host B for error free. Okay. The next one is a session layer. Session layer is used for maintain the multiple users at a time across the world have the access to use these applications. Presentation layer. In presentation layer we have the information in the forms of 0 1 binary form, then they are converted into frames, then they are converted into data packets. These are in binary form which is not understandable by the humans. In presentation layer this binary data is converted into ASCII code and human understandable language. In presentation layer the data encryption and data decryption also done at this presentation layer. The application layer is the topmost layer in which the whole is done for to run an application. Okay, in application layer, for example in Google we have HTTPS, HTTP. These protocols are introduced in this application layer. This application layer provides the user interface to the sender side, at the same time receiver side. These 7 layers starting from physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. This is the schematic diagram. Let us see the functionalities of the each layer one by one. Let us see the functionalities of the physical layer. In physical layer we transfer the raw data bits bits in the form of bit is a binary digits which is either 0 or 1. Okay, in computer only understands 0 or 1. This data is transferred between the computer systems. Okay, in physical layer 0 and 1s, example 0 1 1 0 0, this data is transferred from sender to receiver. Okay, 0 1 1 0 0, this all happens in physical layer. Okay, these four are the functionalities of the physical layer. First one is bit synchronization, second one is bit rate control, and the third one is transition mode, and the fourth one is physical topologies. First one is bit synchronization. Bit synchronization is achieved by providing a clock, okay, clock between the sender and receiver. By means it holds sometimes receiver and sometimes server. Okay, it controls the receiver until the sender sends the bits. It holds the sender until the receiver sends the acknowledgement. By this, bit synchronization is happen. The second one is bitrate control. Okay, in bitrate control, how many bits per second, how many bits per minute are transferred from sender to receiver. Okay, for example, 1000 bits per second means sender need to send 1000 bits, which means 1000 binary digits from sender to receiver. With the bitrate control, which may be 1000 or 10,000 according to the based on the systems. This is bitrate control. And third one is transition mode. We have three transition modes: simple, half duplex, and full duplex. Half duplex, full duplex, simple. In simple, it is like one-way route. Only the sender will send, after then the receiver sends acknowledgement. Only one way is used. Only one way, only one direction. Either sender or receiver, only one. In half duplex, in simple duplex, it is only one way. In half duplex, it is a one way. Okay, this way and this way. In full duplex, both two way at the same time, both are send the data. Okay, the physical topologies is nothing but how the devices are connected in the physical layer. In the networking devices are hub, switch, these are connected is represented by the physical topologies. Let us discuss about functionalities of the data link layer. In data link layer, we need from physical layer we have the raw bits. In data link layer, we convert these raw bits into the frames. Okay, this is the frame format. Frame has frame header, frame trailer, and the data is in between them. Okay, in this, by using this data link layer, we can error-free transmission of the data can be achieved through data link layer. Okay, the functionality of the data link layer is framing, physical addressing, error control, and flow control. Okay, framing, as we know that we convert the raw data, which means the data in the form of this data is converted into frames. Okay, this may be one frame and this may be another frame along with the headers and having the tails. Okay, in this format this data is divided. This functionality is known as the framing. And the second one is physical addressing. Okay, we divide this raw data bits into number of frames. How these frames are transmitted from sender to receiver. Okay, for example, I have a email. I have to send a email to my friend. I have a source address and also the destination address where to send. Okay, in the same way, this data also sent to destination. So for that, physical addressing is added to this data frames to reach their destination, which means the receiver side address. Error control means we have to detect the errors and we control the errors. Hamming code, cyclic redundancy check, CRC, vertical redundancy check. These are the deduction techniques, and we can control. Hamming code is the error control technique. Flow control. If the sender, here he is the sender, he sent this raw data converted in frame, these frames to receiver. The number of frames or the bit rate, the flow, okay, he sends 1000 frames per second. This speed is continuously maintained from sender to receiver. Okay, if you check any time, this 1000 frames per second is to be constant. If the speed is 1000 per second at one time, 500 per second after some time, which may catch to the, otherwise the data may be corrupted, which this speed changes or this rate changes is helping the, which means the data is corrupted. Okay, for this flow control means same constant speed of the data maintained in data transmission. Let us see the functionalities of the network layer. The first one is routing and the second one is logical addressing. Routing and logical addressing. What does the network layer do in OSI model? In network layer, which suggests the best route to travel these data from source to destination. We have the data packets. Okay, these data packets are sent from sender to receiver. These data packets are sent from sender to receiver. Okay, by physical medium. Okay, we send this data by physical medium through wires. Okay, in which path or which route is best to transfer these data packets is done in the network layer. It suggests the best routes. Okay, for example, this is the physical medium. Okay, which route is best from source to destination or sender to receiver? Source to destination. Okay, for example, these two are the best. Some data packets are sent through these, and some data packets are sent to these two routes. These are collected at the destination and this is received by the receiver side. Okay, routing means which is used for the functionality routing, which find the best path to transmit the data. Logical addressing means here there are two paths are used. Okay, we have the physical addressing means the IP address of the sender and the IP address of the receiver. Okay, we have n number of, there are more number of data packets. Okay, physical addressing means the IP address. Whenever come across to the logical addressing, there are different paths. Okay, these paths are finally meet at the destination. Okay, these data packets and these data packets are finally reach at some. Okay, this is given by some address is known as the logical addressing, which route the data packets are transferred but they finally meet at destination, and that address is called the logical addressing. Of the transport layer, what happened in transport layer? Let us see. In transport layer, the data or the message which is sent correctly or not, or the acknowledgement is received from the receiver, is all done at the transport layer. Okay, the two functionality of the transport layer is segmentation and reassembling, and the second one is the service point addressing. Okay, in transport layer, this data is divided into small parts. These small parts are known as the segments. Okay, these segments are transferred to the receiver and these all are collected at the receiver side and cross checked. The data is completely end to end transmission. End to end transmission. Okay, which means the data from server to receiver is completely transferred or not is checked. Okay, first we divide it into small parts called segments. Okay, these are from sender to receiver. These are divided into small segments, and these are collected at the receiver side. These segments are collected at the receiver side, and check the end-to-end data translation is done correctly. The whole message is transferred correctly or not. Okay, the first is segmentation and assembly, reassembling. Okay, segmentation means dividing into small parts is known as the segmentation, which is done at sender side. Reassembling means collect these small segments and combine into a single at the receiver side is known as the reassembling. This is the functionality of transport layer. And next one is service pointing addressing, to deliver the correct information, the message, to deliver the correct message or correct data. This is a service pointing addressing is includes in transport layer. Okay, these are the functionalities of the transport. Let's see what happens in presentation layer and functionalities of the presentation layer. Presentation layer functionalities are translation, encryption and decryption, compression. Okay, in presentation layer, the data which is received in the form of the binary 10101. Okay, 10101, this is in the form of the binary. Okay, what is the ASCII code for 1010? It is the A. Okay, for example, the sender want to send the A information to the receiver. Okay, it is first in physical layer, it is in the form of the binary digit in sender side, and it can be represented by the by the presentation layer in the form of the A. This is happened at the presentation layer. In the form, all data in binary form is present in the form of the human understandable language. Okay. Translation means convert the binary code into the ASCII code or user understandable code, which is the presentation of the binary data into the normal ASCII code data. Encryption or decryption, this is used for the security purpose. We all know about the encryption. Encryption means we add some code to the data at server side. This key, okay, this is means we lock the data with some encryption, means we can lock the data with key, and this data is sent to receiver. At receiver side, using this key we unlock this data. This is known as the decryption. Okay, for security purpose we use encryption and decryption. Compression means if the data is too large, it cannot be transferred easily through the medium, so we can compress the data, reduce the size of the data. It is easy to transfer the data without any information loss. Okay, these are the functionalities of the presentation layer. See, functionalities of the session layer. Session layer have these functionalities. First one, session establishment and maintenance and termination. Session establishment, maintenance and termination. Synchronization and dialog control. Session layer allow different users to maintain a session in between them using different machines. Okay, these three are the functionalities of the session layer. Session establishment means establish a session between the two users and maintain the session. At the end we can terminate the session. And synchronization means we have some checkpoints. Okay, by synchronization we can identify some errors, whether the data can be arranged in the correct manner or not. If the data is arranged in the wrong manner, we rearrange the data. In dialog control, it can allow two or more systems to start communication with each other in full or half duplex mode. Okay, this is happened in the session layer. At the same time, in application layer we have so many protocols. This is the overall review of the OSI reference model and the 7 layers of the OSI reference model along with the functionalities. Thank you.